variations in production pallet thickness do not affect product height on a Columbia machine. We all deal with steel pallets on our machines, and we also deal with tolerances on the thickness of those steel pallets. On our pallet spec sheet, we call for a pallet tolerance in flatness of 15 thousandths of an inch. We don't always get that, but the mill spec on plate steel is not going to be much better than that. And so that, in addition to another spec on the on steel pallets, is a 1/16 of an inch in flatness. So right off the bat, with brand new steel pallets, we're dealing with a thickness variation and we're dealing with a flatness variation. Combined, that's about 3/32 of an inch, almost 1/8 of an inch. Now, in addition to that, as a plant runs, of course, you get buildup on the pallets. And depending on how well we maintain our pallets, that buildup on the pallets will increase that variation because it won't be consistent from pallet to pallet. Another variation that we deal with is when we introduce new pallets into a plant and we mix new pallets with old pallets. And now you're going to have even more pallet thickness variations. And so we have this pallet thickness variation, which is just something that we can't get away from. But on a Columbia machine, it won't affect the product height variation. And we need to talk about how that happens. So I've made a sketch here that we'll go through to explain why pallet thickness does not have an effect on product height on a Columbia machine. And here I've drawn the mold. And in a Columbia machine, the mold is directly connected to a vibrator shaft. And this is an eccentric shaft that, as it rotates and turns, it will move the connecting shafts up and down vertically, moving the mold up and down vertically. And so the mold will move through a fixed vertical amplitude, no matter what the forces on the mold. We present the pallet to the bottom of the mold in a Columbia machine. So here we have the stripper beam, and as it's raised up to seal the bottom of the mold, the pallet rides on our pallet table assembly mounted to this beam. As the mold vibrates, the pallet is presented to the bottom of the mold, supported by airbags which act as springs. And so as the mold moves up and down, the pallet actually strikes the bottom of the mold in different positions. It's very random, but it does strike the mold in the mold's uppermost position. That establishes the bottom position of the finished product in the mold. It's the bottom of the mold in the mold's uppermost position. The top of the product is determined by the bottom of the shoes, and the shoes attached to the mold head assembly, attached to the compression beam, then are driven down so that the shoes contact the concrete, and as the mold is vibrated, these shoes then will sink into the mold, consolidating the concrete uniformly in the mold until such time that we make contact with our height stops on either side. And this gives us an electronic signal that our heights have been made. And at that point, the vibration stops, the product is stripped out and exits the machine. And so, to repeat, The product is determined by the bottom of the mold in its uppermost position, and the shoes determined by a physical contact of the shoes through the beam, through the height stops, and this position here between the bottom of the shoe and the bottom of the mold determines the product height in a Columbia machine. And this is a unique feature of a Columbia machine using CVT.